Welcome to the Getting to Know LXI video series brought to you by the LXI Consortium. Today's video, Going the Distance with Wireless LXI, is brought to you by Neil Forcier, Application Engineer with Agilent Technologies.
My name is Neil Forcier. I'm Application Engineer with Agilent Technologies, and I'm talking to you from Loveland, Colorado. Okay, so let me get started. So let me get into going the distance with Wireless LXI. So the basis for this section is, let's say I need to do testing outside of my office or my lab. Maybe I'm testing a solar panel that's right outside or a couple hundred yards away from the building. Maybe I'm doing distributive tests over a high-speed rail line where I'm doing data acquisition every couple miles to measure vibration. Or maybe I'm monitoring some distant base station or distant transmitter. Or maybe I'm monitoring transceivers that are spread all across the country. And in these types of setups that I'm going to talk about, we can either have the instruments there by themselves, and maybe the instrument's a data acquisition type instrument where it can scan or data log on its own, and we just need limited connectivity to initiate it, to check on it, and to grab data from it. Or these scenarios that I'm going to talk about, it could be the situation where we actually have a computer on site with the instruments, but we don't want to make frequent trips out to the site, and we want to be able to poke in on that test system and grab data from it. And once again, the idea too is that there's not an Ethernet connection around for us to easily connect. So I'm going to talk about three methods to do this type of testing: long distance, remote control of an instrument, or a test system. So the first one is a fairly simple one, Wi-Fi repeaters. And once again, Wi-Fi repeaters is typically a capability that's built into most off-the-shelf wireless products, such as a Wi-Fi router. And it's simply taking a signal and rebroadcasting it. Now, fortunately, they also make industrial versions, which have much stronger antennas, which are much more rugged, and which can handle an outdoor environment. And you can even see one in the picture that has a solar panel for basically powering a battery or powering the device without a power line connection. This is for test applications where you're testing outside of the office at some type of range, or maybe a alternative energy device such as a solar panel that may be 400 yards, 500 yards from your office, and you just need to extend a network to pick it up. With high-powered antennas, you can extend a Wi-Fi network with a repeater, up to a mile. Of course, are you extending a Wi-Fi network, a private one for testing purpose, or are you trying to extend a company's one? If you're trying to extend your own company's Wi-Fi signal, once again, that's something you have to work out with IT. So simple case, simple setup, Wi-Fi repeaters. Another way to do it is using long-distance RF Ethernet bridges. So we talked about bridges in the beginning. Once again, we talked about the consumer version. This is more for long-distance communication, where the Wi-Fi bridge takes an Ethernet, wired Ethernet signal, and it has a built-in transceiver, and it rebroadcasts it in a 900 megahertz RF ISM band. Now, typically these devices, what's nice is they have built-in encryption standards for secure communication. Once again, one of them will be a access point bridge, which will be connected to the computer running the test, or the computer that you want to connect to the remote network, or connected to the same local network that the computer is on. And then you have the slave unit, which is connected to the test system, or the remote portion of the network you're trying to extend. And this is also great for distributive tests because you can typically have a single access point control up to about 16 slave units. And the idea is the range on this depends on the topology around you and how many walls you're going through. But with a better antenna, I've seen these advertised to get up to 15 miles line of sight. I did some testing with them, and I was testing them at a couple miles without any problems through a couple of large building walls. One thing to note, though, on these is they do have latency. So you're not going to be able to control a test system real time from a computer in your office at a test system located a mile away. Once again, though, it's great for controlling data acquisition type instruments, which just need to be set up, triggered, or you can use it to remotely log into a PC that's at a remote site. Then finally, let me get on to the third method, and that is cellular routers. So cellular routers are just like the off-the-shelf routers I talked about earlier, the ones that we have at home are Wi-Fi routers, except instead of using wired Ethernet to access the internet, they typically can do it two ways. They can do the wired Ethernet, and they can do connect to a cellular network, and they're using that cellular network to access the internet. So to use a cellular router, you need a subscription service with a cellular provider, and you need a mobile broadband USB stick. But the idea here is with a cellular router, you can now connect to devices or test setups or information or anything from across the globe, as long as there's a cellular tower in range. Also, we're not restricted by movement. If for some reason we wanted to test some type of moving vehicle, the cellular network can do handoffs. So once again, we can do that now all of a sudden with the cellular capability. One thing to note is there is security concerns when we're using a cellular router because we have to open up the cellular router's firewall to get into the instrument or test system it's connected to. And yeah, one last thing about the cellular router also is the idea that it typically does not come with a static IP. Remember how I mentioned in the beginning that a router to a network, to the network it's connected to, is a layer of abstraction to whatever devices are connected to it. So it has its own IP address, or you could say the mobile broadband device has its own IP address. And one thing that most cellular providers do is they will change that IP address on some type of cycle. And that's really bad if we want to connect instruments on the cellular router, because if that IP address is changing, how do we know what it changed to? So one thing you can do, and one thing that I did in my testing, was I had to work out a deal with the cellular provider to get a static IP. And for instance, if you're in the US, my provider was Verizon, and Verizon had a way to get static IP address, and they charged a one-time fee of $500. Okay, so we talked about the three methods to access instruments remotely, wirelessly. Of course, this discussion wouldn't be too complete if we didn't mention, okay, what if we're in a remote area that doesn't have Ethernet? We may not have a power connection. And the idea is there is solutions out there for that. I think people know that. The most known is either a generator or a battery system with an inverter. Today, the battery systems with the inverter, which is probably the preferred way to go, are fairly advanced with the ability to give you hours of power, to set timers for when the power turns on and off, to give you actually network control or Ethernet control of those devices, to set those timers and turn them on and turn them off. And then they can also be recharged by alternative energy means such as solar panels, and they have connection for wind devices, and of course they're being connected to a generator or AC line. Okay, moving on to getting around firewalls and network security.